Now we're going to look at some trickier simultaneous equations where we're going to have to manipulate both equations in order to solve them. Here's our first example. I want you to have a look at this system of simultaneous equations, and I want you to first of all see how they're different from the previous examples, and I want you to just take a minute to think about how you would go about solving these ones. And we still want to use elimination, so we still want to eliminate one of the variables. I want you to think about how you might go about that. In order to solve these simultaneous equations by elimination, we have to make sure that one of the variables are the same, have the same coefficient in front of them, so we can eliminate them. Now, we could do this with x, but I've chosen to use y. And what I'm going to do is I'm going to take equation 1 and I'm going to multiply that by 2, leaving me with 4x plus 6y equals 34. And on the next line, I'm going to take equation number 2 and I'm going to multiply that by 3. And you'll see why in a second. So I'll have 21x plus 6y equals 102. Now, you'll see that 6y and 6y are the same, so now we can eliminate them. If I call this equation number 3 and this one number 4, we'll subtract the smallest from the largest, so we'll do 4 take away 3, and that gives us 17x. The y's cancel out, and 102 minus 34 is 68, so 17x is 68. And then we'll divide both sides by 17, and as if by magic we get x equals 4. And just as before, we can substitute x back into, let's pick equation number 2 this time, and we can say that 7x plus 2y is 34, so 7 times 4 plus 2y equals 34, which means that 28 plus 2y equals 34. So let's take away 28 from each side, and we get 2y equals 6, and then y equals 3. So our answer to this question is x equals 4, y equals 3. Underline that, and you can go back to the top and you can check it by substituting it into equation 1 if you want to double check that. So here's an example that I want you to try, showing all your working out. A couple of things to remember about this one. Just think about the signs in front of the variables, and think about whether you want to choose x or y to eliminate. You could have chosen either x or y to eliminate in this example. I'm going to choose x simply because we haven't shown that in the example so far. I'm going to start off by multiplying equation 1 by 5, so I get 20x take away 15y equals 30, and I'm going to multiply equation 2 by 4, and this means that our x coefficients are the same, so I'll have 20x take away 20, rather plus 20y equals 100, and I'll call that equation 3. I'll call this one equation 4, and now I can subtract equation 3 from equation 4. So we'll do 4 take away 3. So our x coefficients cancel out, and we have 20y take away minus 15y, so two negatives coming together, so we have 35y, and we have 70 here. So then we just divide each side by 35, and we get y equals 2. We substitute that back into equation 2, and we have 5x plus 5 lots of 2 equals 25. So we can say 5x plus 10 equals 25. Take away 10 from each side, and we get 5x equals 15. Divide each side by 5, and we get x equals 3. So our answer to this one, we have x equals 3, y equals 2. And as ever, we can check that by substituting it into 4x take away 3y equals 6.